MIT में पढ़कर हम चलते हैं सक्सेस की ओर। MIT Group of Academic and Research Institutions, Aurangabad, Maharashtra, announces admission in engineering and management with 40 years in technical education, over 12,000 plus students, best placement cell in world-class companies, best infrastructure. Bead Bypass, Aurangabad. Call 0240-237-5375 or visit www.mit.asia.
Namaskar and good afternoon. I, Shailesh Biradar, Assistant Professor, Department of Electronics and Telecommunication Engineering, Maharashtra Institute of Technology, Aurangabad. Welcomes all participants for Day 3, second session of International Technical Symposium on Opportunities and Challenges in Industry 4.0, organized by Industry Cell and Department of Electronics and Telecommunication Engineering, MIT Aurangabad, supported by GIZ MSME INNO project. Before proceeding to session, some important guidelines for participants. Guideline number 1, GoToWebinar has built-in feature to record attendance. Along with that, we are also recording the attendance using Google Form, the link of which will be circulated during the session for 20 minutes using Telegram group and also in GoToWebinar chat box. For asking the questions or queries for this session, a Google Form link will be shared separately during live session on Telegram group and also in GoToWebinar chat box. You are requested to raise your questions through it. Guideline number 3. Based on the contents of the session, a short quiz along with the feedback form is shared with you at the end of the session on Telegram group. Performance in the quiz has to satisfy at least 40% marks. The link of feedback and quiz will be made available till today 6 p.m. For the session, we have an eminent personality with us, Mr. Kiran Natraj, co-founder and CEO at Entrib Technologies. Welcome, sir, to the symposium. Mr. Kiran has 25 plus years of experience in software industry, working with companies like Wipro, Cognizant, and Persistent Systems. Has an handled complete product life cycle development, means from marketing requirement till sustenance for multiple releases and multiple products. Mr. Kiran co-founded Entrib, a strong 30 plus members team of young techies with an average age of 27, and takes a great pride in sharing how they have saved several hundred thousand of dollars for their clients within just 1 year of launching of Shopworks. Shopworks has not only improved productivity but has also significantly reduced part rejection rate up to 10% for their clients, with an endeavor to make machine shop floors more intelligent by way of connecting them to ubiquitous smart devices. They are really playing a key role in this world of Internet of Machines. Today, Mr. Kiran Natraj is going to enlighten us on the topic technology skills for IIoT. So participants, gear up for the session. Here, I am handing over the session to Mr. Kiran Natraj. Over to you, sir.
Thank you, Professor. Thank you for the introduction, and it's a pleasure to talk to. Always a pleasure to talk to young people who are, still starting out in their journey, so to speak. And what I'm hoping to achieve today is to give you an insight into what type of skills you will need. What are the opportunities that are out there from a work perspective, from a software, from a hardware, or from a general perspective. And I hope one of you, or at least most of you, will be able to choose the right skills that you want to develop and make a career in this space. And before I start out, so anything that you start off with, you have to understand, is there an opportunity, right? And IoT, all of you now, I think, pretty much know what, at least at a broad level, what IoT is and what IoT stands for. But just to throw some numbers at you, right? Just the Indian industrial IoT market is at 15 billion USD, right? So there's a lot of opportunity within India itself, not to mention the world. And globally, this is growing at around 21% CAGR. So that is a cumulative growth of 21%, right? And worldwide IoT spending, in spite of what we are seeing these days, from a downturn perspective or post-COVID perspective, it still remains optimistic. And if you look at the industries that are served with this, primarily manufacturing, transportation, and healthcare. What I'm going to talk about more is related to specific use case of manufacturing operations, and that itself is like around 157 billion business. And apart from that, you have IoT usage in smart buildings or in freight monitoring, and I'm not even covering transportation or healthcare, right? But at the end of the day, so what is a basic message? That there is money to be earned, right? How you do it, what you do is, I'm hoping you will get a little bit of insight into that. And before we begin, what is industrial Internet of Things, right? And the next slide is going to be the answer to all your questions. So this one image that you should take away with you and help you in defining what is industrial IoT. It is this. You know the story of the elephant and the blind man? Industrial IoT in some ways is like this. It is different things to different people, right? If you talk to, so depending on whom you're talking to or what aspect you're looking at, you can end up presenting industrial IoT in a different way. So why this is important is because it is obviously confusing, but confusion also means opportunity. Opportunity to try out things, opportunity to make money, and you need to leverage on this. What is our view of industrial IoT? When I say our view, that means working over the last 4 or 5 years in this space, we were one of the early pioneers. So if you look at a manufacturing plant where you have multiple shop floors, where you have utilities in terms of compressors, chillers, so you have a lot of data that's being generated, and erstwhile all the data would reside in silos in different places. And if you wanted to find out issues, or if you wanted to find out how you can improve your efficiency, it would be very difficult to do that. What industrial IoT enables at its very basic is to try and get all that data to one place. So be it production data, be it machine data, be it operational data, or be it even manual data that can be captured through mobile apps or tablets. So all this coming into one place where you're analyzing it, making sense out of it, and even helping that to improve your operations. So that essentially is how we look at industrial IoT. If you take it right to a shop floor perspective level, you can start at industrial IoT offering you simple solutions like real-time production monitoring, real-time energy monitoring, predictive and preventive maintenance, quality inspections and analysis, and even extending it to a customer side to do remote monitoring or get inventory updates if when your parts are being shipped, and right from production to tracking your part. And of course, all that can be done sitting in one place where the management is looking at a real-time dashboard, where people are planning better based on the analytics that all the data is providing, where maintenance becomes easier because you have now data with you on the status of machines and what was earlier being done on the machines. So all this kind of helps in ongoing operations from an industrial IoT perspective. So what are the driving factors? All of what we are doing, a lot of people will say, hey, nothing is new. But why is it getting so much attention now? One of the key reasons is affordable hardware. When smartphones started coming out, one of the big things that got a push was sensors. So you look at your average smartphone, the amount of sensors that are available in it are fantastic. What this does is it drives the cost of these sensors down, because if you have an accelerometer, you have fingerprint sensors, you have cameras that are being produced in such large scale, the overall cost of that will go down. So now suddenly, where you were looking at maybe $100,000 kind of a project, the cost is now 1/10 of that, right? And there is a what I call as platformization of IoT devices, where you have hardware like even a lot of you would experiment with Raspberry Pis, Arduino boards. So all of these now it's very easy for anyone to buy and experiment with, right? So that of course means that the solutioning or the proof of concept or the innovation around that has become easier to do. Cloud and connectivity. When we started out 4 or 5 years ago, we used to struggle with a lot of implementations. A lot of our implementations would be on-premise because the cloud, although cloud connectivity would be there, the bandwidth to cloud would be pathetic. So you're just looking at like a 1 Mbps connection. But over the last couple of years, we've seen a really good push on the infrastructure side. We ourselves now have a 100 Mbps line to the lease line to the cloud. We can, once you have that kind of connectivity, you can do more. If you look at what Amazon is doing, what Azure is doing, they're highly, and even Google, they are being very aggressive in providing you infrastructure on the cloud to be able to try out different things at virtually no cost. There is a lot of standardization that's happening for you to link up things, connect things, and of course, because you're working off cloud, availability becomes much more easier. Of course, India being a software powerhouse, you can easily do more and more because a lot of you, I'm sure, are just looking at software development. And of course, without forgetting big data and analytics. Why this is important is because what we're doing these days, if you were to do it, maybe around 7 or 8 years ago, would mean you need a full-fledged data warehouse. You need servers like, with really high configurations, high specifications. That really blows the cost for this out of proportion. Now you have all big data concepts where you can actually, scale as you go on the cloud. You can do so much more with this kind of distributed processing power that's also available. So all this has resulted in an increased adoption, or at least the willingness to look at industrial IoT solutions. So what goes into making an industrial IoT solution? So what do you need? And this is the basis over which you can decide where or what type of skills you would like to pick up or you would like to be doing. The first and foremost is a domain know-how, which typically would come as consulting. So for all those who are starting out, this would obviously not be there with you right now, but you have a lot of people who are available, who can give you this know-how, who know how manufacturing stuff happens, who know how machines work. It is important to engage with that. And over a period of time, you would end up building this skill set. And you could, take your career down a consulting path as well. You, of course, need to understand machines, even though you might not be able to understand really how it works. But if somebody tells you there's a CNC machine, you should know what a CNC machine does. You should know at the basic level how it works. You need to understand what is the automation that goes behind it. All this is important because when you're building a solution out, people will be talking about this and your solution effectiveness is better, right? So if you're coding something up and without understanding what is at the end of that or the end usage of that or where it's going to be interfaced with, that becomes very ineffective. There are people who are going to be needed with electronics skills, hardware and sensor design. So where you're looking at, building out sensors, you're building out sensor devices. You're looking at embedded software, because once you're working with sensors at the first level interface point is embedded in real-time software. You, of course, I spoke about big data. You need to have, there's a whole avenue in big data that knowledge and skill sets that are needed. Analytics advanced, you're capturing a whole lot of data without understanding analytics or making sense out of the data. You'll not be able to present it anywhere. You will need to understand what is the infrastructure that goes into setting some things up, what is available from managing your devices, what kind of clouds are there, Amazon, Azure, Google, what are their strengths, what can you leverage on directly. And the last thing and not the least is, of course, security, which forms a separate discipline by itself, right? So all these put together go into making an industrial IoT solution. So now we know the basic things or what was there. Now let's start by deconstructing an industrial IoT solution and looking at what specific skills are needed out there. So this is an example of a manufacturing shop floor, a tire manufacturing shop floor, where we ended up digitizing more than 240 machines, where you can see dashboards like these giving production data out, interface terminals for the operators to see what kind of production is happening, and interact with the machines. So when you're looking at this, you first of all need to understand what are the types of machines. So here there would be curing presses, there would be tire building machines. And if you go away from a tire manufacturing shop floor, you could be looking at injection molding machines, CNC machines, special purpose SPMs or special purpose machines, robots. More and more robots are coming in. So all these you need to have an understanding, and you can build a skill set in that itself as well. You of course need to understand controllers and automation. So you could you will have engineers with skills related to PLC, that is programmable logic controllers. So these are the controllers that actually control the machines, and they're able to automate things around the machine. So if, for example, an injection molding machine is producing a part, you may end up having to do automation to pick up the part and put it in other place, which leads to robots. So you have a robot doing that. Robotics by itself, of course, is in itself a field, but here at least the understanding needs to be there of how I can interface with a robot, what is the data that I can get from a robot, and of course the entire domain part, which is, this is a tire manufacturing shop floor. What is the process of getting a tire done? Now this skill set, as I said, will not be there with you immediately, but once you've worked on an industrial IoT solution, you will be able to absorb some of that skills, and it becomes an important part of your skill set, right? So this is how one can start with machines, and this is the skills that are needed at a machine and controller level. So here you're looking at PLC programming, you're looking at doing automation, you're looking at robotics, and this is one part of what we're doing. Now the other part, if certain amount of data of course comes from the machines, but if you're implementing an industrial IoT solution, you need to be looking at adding different sensors as well, because most of the machines, although they will give you data, there is surround systems, like for example a tire building machine will need a coolant or will need a nitrogen supply flow, which needs to be monitored and measured, right? So there is a skill set that is needed to be able to build some of these sensors. So if you're starting out as an engineer right now, you could look at doing your masters and even essentially your PhD in some of this, where you can end up building a lot of these sensors that are being used everywhere. Here you would need to have a knowledge of, I'm taking a sensor, but how can it withstand an industrial environment? So ruggedizing some of that. So all these things can become a discipline by itself. You could, once so you're working on sensors, or you have people who have built sensors, there is another level of skill sets that are needed, to be able to build a sensor device. Now, what is a sensor device? Say a sensor gives you an output. So the flow meter, for example, is giving you a differential flow of the input versus output. Now that could be in the form of a basic analog nature. So you need a device to be able to convert it into a digital form so that you can push that data out and do maybe a little bit of processing there itself and push it out to the field over a particular protocol. So this is becoming a discipline by itself. There are a lot of people who are building careers by in kind of building a lot of companies who are becoming product companies just on sensor devices, be it cameras, be it these vibration sensors that are there. There are a lot of startups. There's a company in Pune itself called Infinite Uptime. You can look them up. They're doing a good job in uh, building a maintenance kind of a module which is being used worldwide. There is a skill set that's needed for solutioning or understanding what type of sensors are being used where, right? So if I'm looking at a motor, what type of vibrations do I need to monitor? Is this a huge motor? What are the limits of the vibrations that I need to measure? So what is the accelerometer within a vibration meter doing? So all this by itself is a knowledge that of course gets built over time, but there are people whom we kind of reach out to, consultants and engineers who are able to tell us this pretty much easily. So you could be looking at a career which is understanding how these sensors work, what type of sensors get used where, and be able to recommend the sensors as well, right? And this is a fairly important skill set, because if you don't get your data correctly at the base of your industrial IoT solution, it's like a garbage in, garbage out. Data coming in is not proper, you're not going to get, you have failures rates because the sensors are failing often, you don't have reliable data. So this by itself becomes a field. And at the lower end of the spectrum, you could have people who are just doing pure connectivity, deployment related configuring, and these are more field oriented jobs that are out there. So you could go set up, configure, and so you can even start your career out doing just deployment and learning on the job, and moving up to the solutioning part where you understood enough of um, sensors to be able to propose solutions as well. So that's a career path, especially if you're an electronics engineer, whether you're a mechatronics or even a mechanical engineer with understanding of PLCs, machines, and protocols. So this is something that you could look out and at the starting of your career. So once you've connected the machines, you've connected the sensors, the next part where things start getting more interesting is, and these are newer age stuff that is happening, is what we call as edge devices or gateways. So these are devices that are closer to the machines, and the responsibility is to acquire data, right? Now here, what are the skills that are needed? So you could need skills related to programming PLCs so that you can get data from PLCs. You will need skills related to configuring specific devices. There are no standardization, but a lot of the bigger companies, right from Siemens, Mitsubishi's, Intel's, even companies like Advantech, are now started selling IoT devices and the ability to configure them from the cloud. So you will need to understand on how to configure some of these and connect some of these as well. A big part of the knowledge is the protocols. There are tons and tons of protocols that are out there. The more knowledge you have about this, you will be able to even work on building a protocol. So one of the biggest challenges that we see is lack of standardization. So there is a lot of push for OPC UA to becoming a standard as a protocol in the industrial IoT. But if you look at the actual field, actual machines that are out there, there is a huge scope for something new to come up and standardize, either from a protocol perspective or even from building gateways or building. So you could build a skill set doing protocol convergence, and this is a little bit more of a skill that you would probably either as an electronics engineer be more comfortable with, or at a embedded or a real-time software developer. right? Which brings to the next level. There is a lot of work happening on the embedded side, wherein you need the capabilities to run machine learning algorithms if you built it in Python, but more in real time. So optimizing these algorithms, making them fast enough to be running on more and more standardized hardware. This is becoming a very important skill that is being needed. So if you want to play around with devices, there are a lot of devices and if you are looking, and quite a few of you would be looking at machine learning algorithms, you need the ability to understand how you can do more processing on either a graphics unit or a GPU, or what are the how because you are pushing the boundary on some of the processing on this. So this is how you would kind of move up the value chain as well. And once you acquired all the data through your gateway, you then look at visualization. These are some of the sample dashboards that we end up displaying on the shop floor, because these help in give visibility on what is happening. You may be doing a lot of analytics behind the scenes. At the end of the day, maybe somebody is just looking at a number, but they need to be looking at it at the right place in the right form. And this becomes an important skills wherein you are working on developing really good user interfaces, right? So interfaces, so what happens on a manufacturing shop floor, the user interface there may not be close to what you are used to doing on a normal, in your day-to-day normal activities. But because here, if you want to provide visibility, then you need to use solid bold colors, like you need to use red. So there is a whole UI and usability skill set that is needed as a discipline for manufacturing as well, and that is right now underserved. So if you're able to, if you have an eye for design, but you need you need to do something challenging, this is a upcoming area that you're doing. Which brings me to the what is needed from a software component, or what are the skills that are needed right from your cloud infrastructure. If you look at AWS offers AWS IoT, Azure IoT, Google also. So you could start out by looking at all what I would call as platform as a service offerings. You can build up skill sets just by focusing even on one of these guys. So you could become an Amazon cloud architect. So there is a big opportunity space that's happening out there. Related to that is, of course, big data skills. So understanding what is SQL, NoSQL, understanding how I can distribute my data over different shards, working with databases like MongoDB, working with how you can scale even traditional databases. So that's becoming a good skill set. Then, of course, comes to the analytics, where a lot of people are now focused on. And even if you're not a hardcore programmer, or you're not a hardcore electronics engineer, or you could end up learning skills related to just analytics. These are statistical analytics, different types of analytics that is out there. And I spoke about visualization. So visualization, of course, starts from right from mobile visualization. So Android, iOS programming. But most of our programming we do in HTML5. So we use a cross-platform approach. So HTML5 skills, we use Vue.js, technologies, Vue.js, AngularJS, React.js. So these are some of the skills that are being used. We use a lot of Node.js. So a lot of although our stack is, core stack is Java based, but more and more our programming is shifting to Node.js and Python. So if you're looking at programming languages that are more popular out there, of course, JavaScript and Python is among the top, and it will continue to happen. But if you're looking at firmware level, then of course you also have to be comfortable with cross compilers, working in C and C++. And so depending on your sweet spot, what challenges you, what you're able to understand, these skills you can make a virtual career out of this. The last part of this thing is security. Security is a discipline, is a completely separate discipline by itself. It has not been given the importance so far that it deserves, because people still are not fully connected up shop floors, right? And if they have connected up, then outside access will not be there. So even though there might be some connectivity to the cloud, um, that will probably be very limited. So if you're looking at security as a career option, as a skills, you need to be thinking right from the IoT product that you're at a hardware level you're building out to the cloud, because there is no way you can compromise on security, because more and more devices will be open out there to be able to hack. So most industrial IoT implementations right now don't control machines, but that we have seen changing, because we ourselves at least now give the ability for our customers to stop machines, right? So they can stop machines if something is not right. We don't give the ability to start machines because there is a liability associated with that, but these kind of control will more and more happen. And if you're working, for example, with machine learning algorithms, you need to be able to go and update certain parameters for manufacturing automatically. Now, if you don't have the security in place for that, there is nobody who's going to adopt your solution. So this is this will be the next big bottleneck for large scale IoT adoption. And you need, if you have a hacker mindset with you, if you and I mean this obviously in a good way, that you like to break into systems, you like to look at things, this is a place where you can start building your own products out. There's a huge market for that, and you can make a career out of this. Let's look at some real world problems that we are solving and how some of these skills apply. Because if you're not solving the problem, then nobody's going to pay you money for it, right? So this is an example of something that we have done related to weld shop quality for a big three-wheeler manufacturer. Here there are 160 what they call as spot welding guns, right? So what we needed, so domain know-how, you need to have an expert who at least tells you how the welding is happening, what am I looking at when I'm looking and connecting to a welding machine, right? We needed to have the knowledge of how to connect to these machines. So there were 3 different types of controllers, one of them giving on Modbus, there was one proprietary. So protocol level knowledge is needed. So understanding this becomes important. We said, hey, we need to, once the domain guy identifies that we need this kind of data, what are the sensors that are needed? So coolant, what can you use for measuring coolant temperature? I need to measure the coolant flow, the pressure, and the current. So because all these are contributing factors for the quality of the weld. We had to have PLC knowledge, because what we had implemented was an automated way of not allowing the fixture to be declamped. So imagine there's a spot welding machine, the guy is welding a component, but he cannot unclamp the fixture till the quality is okay. So we needed the ability to control that and say you can open it or you cannot open it, right? And of course the analytics part, because we were capturing all this data, we needed to analyze to see if there were any trend in degradation of these parameters, and based on that, you say that there is a quality issue. So if you see all of this, you're looking at, right from the domain, connectivity, sensors, and of course at the back end you're still your big data, you're still your infrastructure related stuff, right from even from networking to security. Another use case is that we are working on is, and this is a very fascinating use case, predictive quality for iron. When I say iron, it's an injection molding machine where we are collecting process data. We are implementing what we call as a process fingerprint. So in this case, what happens is that process data coming in, we are able to capture in real time, and they're able to compare it with what is the desired behavior of, say, for example, the temperature. So what happens in an injection molding machine is there is plastic that goes in, it's heated up, it melts, it flows into a mold, it cools down, and the part is pushed out. Now the science behind this is, if the temperature or the injection doesn't happen properly, if it's not heated to the right temperature, it doesn't follow a particular cooling pattern, you may have a suspect bad part. So here we are giving the ability for people to figure this out in real time, and updating even the ERP information. ERP is where all the production related data is stored, to saying whether I produced a good part or a bad part. And of course, there is a whole machine learning part to that, where we are building a machine learning model where it will then automatically update the algorithm that is needed to compare or tell you whether this part is good or not, right? So summarizing all this, I'm almost at the end of my presentation. Right from assets, you need to have the knowledge for even like assembly lines, injection molding machines, press machines, CNC machines, utilities. You could have compressors, chillers. You could be looking at entire plants like a paint shop, a sewage treatment plant, an effluent treatment plant. Connectivity, sensor devices, you need edge devices. You of course have the ability to show information on TVs. So programming Android applications for TVs, touch panels which are increasingly running Android and Windows applications. This is an upcoming stream which is edge stream analytics. So you have a lot of data that's flowing in. So if you're interested in this and learning skills like you could look at Apache Kafka, you could look at Spark. So this is basically data that is being streamed, analyze it in real time and give feedback to that. There is of course you can end up, so there's a lot of demand for building out the right hardware for the right solution, because based on the processing needs for example, I may not need the same kind of processing capabilities when I'm looking at data coming from an injection molding machine. But on the other hand, if I'm looking at data that's coming from cameras, I need a lot of processing power because the image processing takes more CPU and GPU usage. Don't worry about the industry specific solutions. You will always have domain experts telling you that. But what I would suggest and recommend is do a lot of internships. Internships give you a very good insight into what actually is happening on the shop floor. Be ready to get your hands dirty, fight for opportunities. It's easy to get an internship in a software company and just sit in one place and do something. That's of course very attractive, but it's also very you will learn more if you go out on the shop floor. You learn more if you see how machines work, see how production process happens, see what are the challenges people face on that. Only when you look at the challenges will you come up with ideas. And I'm sure there are a lot of you who want to kind of start out on your own as well. And this can be a great opportunity. You visit a shop floor, you do an internship, you see a problem that needs to be solved, and go and solve it. On the application software side, tons and tons of software to do. Don't try to reinvent that is something that is there already on the cloud. So look at what is available on Amazon, look at what is available on Azure, but focus your effort or in learning in the right manner. What you see in the bottom here is some of the applications that we end up building for a shop floor. OE stands for overall equipment efficiency. Again, if you know some of these domains, it becomes easier to talk. Then preventive maintenance, why traceability is important, because more and more automotive regulations demand traceability. There is a lot of push towards predictive quality, maintenance, productivity, and there is a big need for making things work in a plug and play manner. So that's a skill set that, or even a software product or a software layer that people can work on to make things more easy to use. Right. So what are my key takeaways? What I would like you to think about? There is lots of opportunities that allow you to go from the mechanical side of things to electronics to embedded firmware and to pure software, and of course even MLAI, which is probably a lot of you just looking at that. But just be careful about ML and AI, because a lot of it is statistics and math related. So if you have a penchant and if you're really good at that, then you should jump right in. But you should have an understanding of ML to be able to build the right kind of a product or right kind of a solution out. The domain know-how will become more and more essential as you progress in your career. So as I said, don't worry about not understanding it right now. focus it on one of the base skills that I talked about, and this will happen as we progress in the career. The hardware and electronic side is tricky to master, but if you are willing to do the hard work now, you will be able to differentiate yourself to that. Because if you are not afraid of getting your hands dirty, again going on the shop floor, you are able to build out solutions that will be more usable, will be more relevant to a lot of people. And one thing that I have noted, at least in this whole journey, is very few people understand end to end. So you'll have people who understand the electronics, you'll have people who understand the soft cloud part of it, you have people who will come and tell you that, hey, use Kubernetes for setting up this infrastructure, or use Docker. There are people who will come up and design hardware for you. But there are very few people who are able to put everything together, right from the sensor to the cloud. And if you are able to understand this, then you are able to become more valuable from a solutioning point. So that is also something that to think about, because there is a career in even understanding or doing this kind of work as well, right? And if you're already in the industry, so maybe you're already working in a manufacturing industry, the key skill to pick up is related to analytics. If you haven't learned how to do, of course most of the people learn Excel, but you will have to still master Excel. Look at tools like Tableau, Click, and even languages like R, Python, which allow you to kind of look. There is going to be a lot of data available there, and if you don't build this skill set of analytics, then you will not have a differentiator with you compared to somebody else, right? You can do more if you work on this. So that's all I had on from a session perspective. I hope that was useful to you, and I'm happy to have any questions. I don't know the format for questions, but I think we can get Shailesh. Can we move to questions?
Yes. Thank you so much, sir, for the efficient talk. We'll have to move on a question and answer session. There are many questions from participants. Since due to time constraint, we will take few questions here. Rest we will cover in the panel discussion. So the questions are Miss Prajakta Dashrath asked about, will you please guide us about best links to start with MongoDB?
Okay.
And
so yeah.
And also she also asked, will you please guide about best links to start with the study material?
Study material, right? So for MongoDB, the best thing to do with is do a MongoDB. MongoDB has certifications. You should look at specific courses on Udemy and Coursera that have, so within MongoDB itself, there are 2-3 things that you can learn. One is on the administration side. So there is a whole skill sets that needed if you want to administer databases. But if you want to do programming, then that's a separate skill. So there are programming level courses on MongoDB. So start out with Udemy or Coursera, and definitely do a certification for that.
Okay. Sir, next question from Dr. Gayatri Phand. Can we convert existing PLC to IoT enabled with some add-on? If yes,
definitely. Yeah, sorry. Is that the whole question?
Dr. Gayatri Phand.
Yeah, okay. So there is definitely add-ons that are coming up. So for example, Siemens recently launched an add-on for, of course, it is for their higher-end PLCs, where you can just plug in that and configure that to get data. The challenge in most cases, even when there is an add-on, is it will still need a certain level of PLC programming to be done to be able to get data. So for example, you have a special purpose machine that has a PLC that is let's say a press, like a simple press that is moving the press up and down. Now In order to get data from this, you will probably need an add-on module like either at the simplest, this is a Modbus TCP card that could be there. But you will also need to change the PLC program to be able to push data out in certain registers. So short answer to your question is yes, it's possible. The longer answer is it may need working with even the machine manufacturer to be able to change some of that. So what ends up doing sometimes is it's easier to add specific sensors to the machine and have your own PLC to acquire that data.
Next question is from Shrikant More Patil. His question is, as sir, as you are CEO of company, so my question is, what problem are faced for selling IoT based products?
So when you're talking of selling, so you cannot really go and sell an IoT product. That is the biggest challenge. What you are selling is the solution to a problem. If you are able to answer that question, then you will not have a problem selling an IoT product. So for example, we have a gateway, an edge gateway, and we have this wonderful software built on edge stream analytics. But if I go to a customer and tell that customer, I have edge stream analytics, he's going to go, huh? Right? I mean, what does it do for me? But if you go and tell them that I can give you visibility into where your operational losses are, I can help you pinpoint your operational losses, and this is how I do it, then it's a much easier sale. So don't sell an IoT, don't sell your product, solve a problem for a customer. That is the only way you are able to sell. And from a challenge perspective, educating my sales team to be able to do this was kind of the biggest challenge.
So the next question is from Karthik Sonar. How mechanical engineering impacts to IIoT, and what are the contradictory parts of the IIoT?
Okay, that's a good question. So increasingly, what's going to happen is, from a mechanical engineering perspective, you would like to be working more and more designing machines, building machines out, or even machines at the simplest level. All of this is changing. Machines are now becoming more and more connected. Right? So, to the question about mechanical, so what you need to understand is that this machine, when I'm building it out, what kind of sensors will I need to integrate into the machines itself, and how that data can be made available outside. That is one part. The contradictory part is primarily driven from a security. So I can make data available, but or I can give the ability to connect this up, but is it secure enough that it can't be hacked? That becomes an issue. The other, I wouldn't say contradictory, but when you're implementing an industrial IoT solution, it's always a struggle between what I can really automate. So if I have certain money that is there, can I make things a little bit more automatic? So simple question is, if I have a budget to implement, and if I say that my industrial IoT solution is going to cost X, but you as a mechanical engineer say, hey, I can put a robot that improves my efficiency on that particular machine by 3x. So that is the contradiction that's going to be there, right? I hope that makes sense.
So next question is from Professor Abhijit Khadke. What are the challenges of IIoT to be solved, like multiple skill set requirements?
Right. So I think that is the crux of the problem. If you want to build a complete solution, you will have multiple skill sets that are needed, as I covered in my presentations, right from hardware, machine know-how, domain knowledge, etc. So how you solve this is, of course, you have to have, it's like a team effort. You will not be able to do everything by yourself. Just remember that. And remember that if you're able to do that, then you are very, very valuable. So you have to have people who are working only on very specific parts. You will need electronics engineers to figure out the sensors, to figure out the electronics part of it. You will need embedded engineers to work on programming, how to get data, to process data. You will need the big data and cloud guys to be able to, make further sense out of that data. So at a minimum, these are the multiple skills that will be needed. And apart from that, there is a underlying skill of solutioning everything together, putting things together. That is comes, of course, a little bit more by experience as well.
Sir, there will be a question of explosive question.
Yeah.
From Mr. Surya Tiwari, is it safe explosive product inbuilt with IoT connected to cloud?
Sorry, what is the question?
Is it safe explosive product inbuilt with IoT connected cloud?
So from what I understand,
So explosive product inbuilt with the IoT, which is connected to cloud. Is it safe?
obviously not. It is not. Whatever said and done, you have to go with the basic premise that your system will get hacked. And if you look at the main thing that your system cannot do is loss of life. If there is any capability of something going wrong and causing loss of life, that is an absolute no-no. To give you an example, right? There is you have gas stoves these days, or you have stoves which are IoT enabled. You cannot switch those things on remotely. It is just not allowed by the manufacturer. So even if you're building a solution out, you cannot build it out such that I can remote switch on the stuff, right? That is something that, of course, there is a lot of governance that is needed, but this is something that that is something that you need to take care about. There will be regulations that come up around this, and I think we are too early, at least in India, from a regulatory perspective. But some of this will be guided by regulatory. And it's a right explosive question, because the same kind of answer. So you as a software programmer, like one simple example. Suppose you're building a autonomous car driving software, right? And you have two obstacles in front of you. One which right in front of you, which is your software detects and tells you it's a human, and to the right, so you have to swerve to avoid it. But to the right is another, child or a smaller this thing. You're programming the software to take decisions. So this is the kind of dilemmas that will end up, with more and more automated systems. So you have to be careful with that. Next.
So the next question is from Muhammad Ali. How IIoT different from computer integrated manufacturing and flexible manufacturing?
And what manufacturing?
And flexible manufacturing.
Okay, so computer aided manufacturing is maybe a little bit of a somehow an older term as well, but it would relate to a very specific machine or very specific process. That is where the computers would have been traditionally used, whereas in industrial IoT tries to look at the complete big picture also. So everything coming on to one place. So I'm not looking at one machine in isolation, but I'm looking at the entire maybe assembly line. I'm looking at the entire shop floor, and then I'm looking at figuring out where the issues are. I'm figuring out what is happening. So that is one of the key differences. And flexible manufacturing is a different line altogether, which kind of will go parallel with industrial IoT, because imagine the factory of the future, wherein there are no humans, but you have a flexible line. So this flexible line today can produce plastic cups, but just using software, I can reprogram it to produce masks. And this is actually happening, right? We work with a German automation company, right? We have a joint venture with them, and they before this before the COVID-19, they were serving automotive manufacturers, right? Their their lines were increasingly be built in a modular manner, like a more plug and play manner, like which is a step towards flexible manufacturing. And so they were able to reconfigure from this and overnight come up with mask making lines, right? So that is like a thinking and different. Now you can still have the same industrial IoT solution that's monitoring the machine, that's looking at the data, looking at the bottleneck, and it is going in parallel with this flexible manufacturing. I hope that answers the question.
So the next question is from Mr. Piyush Late. There is a lot of equipments used to automate one tool which uses shop floor space. Is there any chances to minimize it?
To automate, sorry, what?
To automate the one tool which uses the shop floor space. To automate one tool, a lot of equipments are used on shop floor.
Right.
So how do we minimize them?
If I understand the question, so there is a lot of equipment that you need to be able to automate. It's not a straightforward answer because every situation becomes different. There are different factors that need to be considered when doing such kind of automation, right from how much space do I have to what is the pressure that is needed to maybe even pick up something, to what is the safety aspect, how much of force do I need to be able to move that around. So there's a ton of things that are more overriding than just considering the minimal. So the minimal components is the last thing actually that comes, because the first thing is to be able to solve it from a space, from a safety, from all these particular aspects. Correct. So this is also one of the key challenges, the network connectivity. And this is something that I think at an infrastructure level, maybe it's not right to put it on the government, but I think there is what this whole COVID-19 has shown is there is a huge amount of need to improve the infrastructure, and there is opportunities for a lot of people to think about some of these problems that we face on a day-to-day basis, right? So there is opportunity there as well. So we can go to the next question.
So the next question is from Professor Gnaneshwar More. How a fresh engineering student can find opportunities in IoT-based software industries?
Great, that's like the key question on everybody's mind. So first of all, one is during the course of your engineering, you probably would not have paid attention to a lot of theoretical stuff, but I'm sure most of you have given programming a chance. So you obviously have figured out whether you like programming or not. That is the first level. Now, based on, and if some of you might be, even electronics engineers, etc. You first of all you have to figure out, whether you like whatever you're done. Now, if you've not done anything, and this is so, I have also my, I've got two sons. One of them is doing first year engineering, and I'm telling both my sons to do internships, right? What happens when these internships need not be long internships? They could be, over summer holidays. They could be while you are studying. You could be working as an intern somewhere. This gives you two things. One, it gives you a flavor of what actually people are doing out there. So when you are looking, if you've done 2 or 3 internships, it gives you two advantages. One is it gives you a flavor of what is out there, whether you like it or not, and you can always try something else. The second thing is when you go to look for a job, right? When you go to job, there are a lot of startups out there who kind of need people, and we typically hire from colleges like MIT, IIT, etc. So there are a lot of startups that are looking at skills like, and if I'm looking at somebody who's done an internship somewhere, I'm more likely to hire that person than somebody who just comes fresh out, something like that. So that becomes very important. And from a skills perspective, I would, find what you like from a programming, be it embedded programming, be it electronics, and do preferably an internship in that area, or try to do your own, uh, product or your own solution in that area. Anything that will give you an advantage or a differentiator, so that when you put your resume out there, people will look at it. So these are few things that I would suggest.
Sir, this is the last question.
Yeah.
Professor Rakesh Rostava, good insight, sir. How do institution adopts to these technologies?
So when you talk of institutes, is it manufacturing institutes, or are you talking of educational institutes, or what would be the
Might be the educational institute.
right? I think one of the key problems that I see is, at least, so maybe it's not fair on me to do comparisons, but we work with a few universities, one in Singapore, and one elsewhere as well. So what I have seen in most of these universities institutes is the infrastructure that is there in terms of the machines that are there is phenomenal. So this is a polytechnic university in Singapore, and they have like 30 uh, different types of printing 3D printers, right? 30. They have a 5-axis CNC machine. They have at least 10 CNC machines. So there is one aspect of getting all this equipment in which allows people to really get hands-on knowledge and do more research on. I would love to be able to work with, because for me, for example, I run a small company. I can't afford to put machines out there, but what I can do is, if there are machines, I can definitely have my people work with institutes, work with people to be able to do some projects, do some research oriented projects as well. So for institutes, I think there's a question of how to get that infrastructure in place for industrial IoT. uh, Budgets will always be a concern. So to start with, and a lot of you are doing that, obviously, is getting these kind of kits that are available, be it Raspberry Pi kits. But look at maybe industrial related. Look at least, if not getting machines, but getting you can even approach the Mitsubishis and Siemens of the world to be able to give you controllers, to give you certain even software that can be utilized to set up more of a lab. So think about, you already would have lab, but think about how you can make it more full-fledged, and invite companies like ours. There are quite a few companies, and even in Aurangabad there are quite a few companies that can actually come and do research on this. So this is what I think, at least at a minimum, things can be taken. So I hope that makes sense.
So, so that's all from the question and answer, sir.
Yeah.
On the
Thank you. Thanks for this opportunity. I hope at least a few students would have taken advantage of this, and line their thinking along that lines. Please feel free to email me either at info@entrib.com or kiran@entrib.com, or even my personal email. It's my last name, Natraj, Natraj, @gmail.com. Okay.
hello, hello.
Yeah.
On behalf of Maharashtra Institute of Technology, Aurangabad, and organizing committee of this technical symposium, I, Shailesh Biradar, taking this opportunity to thank you, sir, for an exquisite session and the deep insights on questions from the participants.
MIT में पढ़कर हम चलते हैं सक्सेस की ओर। MIT Group of Academic and Research Institutions, Aurangabad, Maharashtra, announces admission in engineering and management with 40 years in technical education, over 12,000 plus students, best placement cell in world-class companies, best infrastructure.
Bead Bypass Aurangabad. Call 0240-237-5375 or visit www.mit.asia.